Okay, problem number 1, 221. So chapter 2 of the university book, number 21 in the chapter problem. So a fast pitch, usually they name each problem. So a fast pitch. So the fastest measured pitched baseball, okay, left the pitcher's hand at a speed of 45 meters per second. Does anyone know the quick way to quickly go from meters per second to kilometers per hour? Just to give it a physical sense. I mean, meters per second is physically enough, but how about kilometers per hour? Because we're more used to it. Does anyone know the magic number? I mean, you can do unit conversion, right? You can do unit conversion, but there because meters per second and kilometers per hour is so common. Does anyone know the trick to it? Who remembers the magic number from grade 11? Say it. But okay, we have meters to go to what? We have to go from meters to what? Kilometers, and from seconds to what? For hours. Okay. You can do the unit conversion, or you can just remember this quick trick. 3.6. 3.6 is the magic number. Now you either have to what? Multiply or, depending which one you go. Okay, I'll give you the easiest way that my teacher said 25 years ago, and it just made sense to me. So far, I'm in what? I'm in what? Seconds. I want to go to what? So should I shrink or magnify? Exactly. It should get bigger, right? So that means what? Multiply by 3.6. How about if you were in hours? You want to go from hours to what? So do you want to shrink? So do you want to magnify or shrink? You want to shrink. So what do? You divide. Always remember it this way. So 45, can someone multiply 45 times 3.6? Gotta be like maybe 180 kilometers per hour. 45 times 3.6. How much? 162 kilometers per hour as it left the pitcher's hand is so far, or up to the publication of this book, is the fastest what? Pitched baseball. Okay. If the pitcher was in contact with the ball over a distance of how much? So that means what? From here, everyone eyes on me. From here, from the moment they actually started moving it, till the moment it what? It left the hand, it went over how much of a distance? 1.5 meters, okay? And produced what? Because we said that the kinematic equations only work for what kind of acceleration? Constant uniform acceleration, okay? So the question is, what acceleration did he give the ball? And B, how much time did it take him to pitch it? So the first question, what was the acceleration that basically what that the ball underwent or experienced from the beginning until until it what? Until it what? Left the pitcher's hand. Okay, so let's do a very quick sketch. Okay, everyone, let's do a very quick sketch. So what was the initial state of the ball? 0, exactly. So at rest, right? So that means basically it was baseball, yes, and it was not moving. And then he starts to what? Propel it forward. So let's say to this direction. So at some point, it went up to here, and it was going this way. Okay, so let's put some numbers on the diagram. What was the initial speed? 0 meters per second. What was the final speed as it left the hand? No more contact. 45 meters per second. The distance over which the player or the baseball pitcher actually gave it acceleration was how much? 1.50 meters. Okay? Do we have three numbers? Do we have three numbers? Yes, perfect. So we have what? A legit kinematic problem uh, at our hands. Okay, so part A. Part A. So VI equals 0, and no need for units because all of them are standard and nice. Delta D is 1.50. And what is this one? What kinematic symbol should this take? VF, it's meters per second, so it's speed, and it must be VF because we already have VI. And what's the question asking for? Is it asking, at least part A, is it asking for acceleration or time? Acceleration. So A, no need for AAV, is question mark. What's missing from this list? Missing time. Which equation does not care for time? Because that's the only one we can use. Exactly. Number 5, the one without the arrows when you square the vectors. Okay? So V F squared equals V I squared plus 2A delta D. All right? You can rearrange if you like, or you can plug in numbers. It's easy enough to plug in the numbers. So let's plug them in. VF squared is 45 squared. The good news about 0 squared is that it's going to simplify the calculation because it's going to go away. Plus 2 unknown A, known distance. Okay, let's clean up. What's 45 squared? 45 squared. 4.5 squared is 20, so 2000, 025. 2000, 025 equals, this could be completely just, look, eliminated. 2 times 1.5 is how much? What's 2 times 1.5? 3A. Done. That's it. So A must be 2025 over what? Over 3. By the way, I guarantee you that that number divides 3. By that, I mean you are not going to get a decimal. Does anyone know the trick to knowing how any number could divide 3? I always say it when I teach math courses. It's a very, very neat trick. You can look at any number, no matter how big it is, and without knowing the final answer, just know if it's even worth it to divide it by 3. Josh, everyone listen? Exactly. You add the digits, you get the sum. And if the sum of the digits is itself a what? A divider of 3 or a multiplier of 3, that original number does divide 3. So 2 plus 0 plus 2 plus 5, boom, that divides. 9 divides 3. That's it. This number divides 3. I don't care how big of a number it is, even if it has 100 digits. Just add all of them. So what is that answer? 6, 675 meters per second. What? Obviously, technically, what's the direction? Backward or forward? Forward, because it's positive, and obviously it is moving forward in the initial direction of the motion. Look at this number. What does this number mean? Every second of motion, it was gaining how much speed? 675 meters per second. Not just meters, because if you just say meters, it's distance, not what? Not speed. Imagine that much acceleration. By the way, you might say, does that make sense? Well, hold on. Let's see what part B is, and then we can judge. By the way, the answer is numerically correct. It is the correct answer. But let's actually make more sense of it by finding how much time it actually took to what? To get to that. All right, part B. By the way, question, was 675 rounded or exact? So technically, could I assume now I have 4 good numbers about the problem? Yes. So that means what? You actually do have now the chance to what? Use any of the 4 equations that has VI, delta D, sorry, that has, what's the other thing? That has time. 4 equations have every variable, there are 4 equations that have it, okay? However, if you want to go back to the what? To the basics, you can still copy the same first line, but instead of A, you go to delta T. So VI 0, delta D 1.5 meters or 1.5. VF is still up to 45, and now it's 45, and now it's delta T. So what's missing here? What's missing? The acceleration. Which equation has no acceleration? Has no acceleration. The second equation, delta D, VI, VF, delta T. All right. So delta D 1/2 VI, VF, delta T. All right. The good news about VI is that it's how much? Perfect. So this thing is gone, zeroed out. So this becomes 1.5 equals 1/2. Technically, just the 45 survives inside the bracket times delta T. All right, let's clean up. So I get 1.5 equals, what's half of 45? Well, half of 44 is 22. 22 and a half. And the rest is just a quick division. Delta T equals, the unknowing number is 22.5, so it climbs under the 1.5. So 1.5 divided by 22 and a half. So that would, by the way, would that be a very long time or a very short time? Yeah, look, 1.5 divided by 22.5 should be a very small decimal. And the answer is 1.5 divided by 22 and a half. Okay, what's the sig fig situation in this problem? 3 sig figs. 1.50 is 3 sig figs. 40. No, wait. How about 45? Or is it 45.0? 45.0, so it's 3 sig figs. Thank you. So what would that be up to 3 sig figs? Now, does the first two zeros count as sig figs? No, so that means we have to start counting from the first 6. So that means I have to keep 3 non-zero digits, which means 6, 6, 6, and I make my cut right here. I make my cut right here, which means 666, the number of the beast. What would that be? 667. Exactly. So you can, honestly, you don't have to write in scientific notation. It is not super small to actually say that you need scientific notation. So 0.0667. Yes. Oh, yeah, we did the 3 sig figs as well. Sorry. Yeah, but I just remembered to comment that. Yeah. Uh-huh. Yep. Oh, because, okay, 20. Just if you write 20, how many sig figs is that? Remember? So, but the answer, all the numbers in the problem had 2 sig figs. So it had to be forced to look like what? 2 sig figs. And the only way when you get a non-negotiable 0 at the end of any number to make it forced into being sig fig is to have to write it in what notation? Scientific notation. Okay? Make sense? By the way, everyone, just so you know, so when you go to first year, don't say, oh, he didn't tell us this one. I don't want you to practice it as much. I want you to go to scientific notation. But how many people saw this in maybe you've seen it in another chemistry course or so? 20 is how many sig figs? How many? 1. There's another notation to make it look like 2 sig figs. Look, they do this. How many people have seen this before? No one? Yeah, it's still a notation. I've seen some university profs and some high school teachers use it. But what's so weird about this notation is that usually when you see a decimal point, what should follow after? At least one single decimal, a 1, a 2, a 0, something. You're not following it. But this is basically to tell you what? That dot is not much of a decimal point. It's the indicator that you're taking how many sig figs? 2. Sorry, yeah, how many sig figs? 2. However, let's stick to what notation in this course? Okay. And by the way, have we encountered a lot of numbers that end up in 0 in this course so far? Barely. So that means what? You might have to use it like once every like little while. Okay. So that's basically it. So let's not use this notation, although it is legit. I've seen it, but let's stick to scientific notation. Very practical. Okay. So what can you tell me about this amount of time? Very what? Very short. So that means even though, everyone, look at the acceleration. Even though the ball was gaining how much speed per second? How much speed per second? 675 meters per second every what? Every single second. But did it even last for a second in his hand? No. For how much? Not even 7% of a second. Do you see what I mean? So it did gain speed, but was it given so much time to gain it? Was it given a lot of time or a very short time? That's why it only went from 0 to what speed? What if it was given a full second? Then it would have gone from 0 to what? 675 meters per second because you've given it how long? A full second. Is it making sense now? So it was gaining a lot of speed, but it wasn't given a lot of what? A lot of time. So that means it only got up to what? To 45 seconds, which what makes sense. So the answer is high, probably more than you might think it's physically possible. And that's why I told you wait until we get the what? Is it making sense now? Don't just wait for a number to actually, don't just look at one number. Calculate from the perspective of another number. That's how physics goes and logical thinking. Okay? Awesome. That's it. By the way, this is how they present what do you call it? University problems to you. By the way, did they tell you what units to express your answer in? No. They basically just what? Leave the units up to you. Sometimes you might need to do a unit conversion. Sometimes you might need to do a scale conversion. It depends on each one. Okay, let's do the next one. Okay, whenever it says bio, it basically means this question is physics, but it also has biological application, okay, like biophysics. Okay, so if a pilot accelerates at more than, who knows what 4G means? How many people have heard of, 4G, 5G, G forces, and so on, if you ever heard it? Raise your hand if you heard that. Okay, what does it mean, 4G? Well, first of all, what does G mean? I know we haven't covered it. That's tomorrow's lesson. But what does G mean? It's literally the same thing we did in grade 11 physics. Say again? The what of gravity? The acceleration of what? Of gravity. So for example, if I let this go, okay, immediately, once I leave it, what's the initial speed? Right now, what's the speed? 0. Once you let go, what's going to happen to it? Now, is it going to fall at a constant speed or at an ever increasing speed? Exactly. That ever increasing means it's what? Accelerating. And the G, the small g, is always the what? The gravity acceleration of what planet? Where? Near the what? Near the ground or near the sea level, as they say. Okay? So what does 4G mean? What does it mean when you say a pilot is accelerating at 4G or 4Gs? Exactly. So, okay, look, everyone. Let's see how long it's going to take to fall. Did it even take 1 second or slightly less? Slightly less. Imagine this pilot is speeding up 4 times that much. By the way, does anyone know the magic number for G, which we will cover tomorrow? 9.8 or 9.81, depending on how you look. Let's say 9.8. So that means what? Every second, once you leave it, it's going to speed up by how much rate? 9.8 meters per second every single second. What's 9.8 times 4? Well, 9.8 is very close to what? 10. What's 10 times 4? That pilot is being sped up at how much rate? 40 meters per second every single second. By the way, could that be dangerous? Why? What does it take to push someone that fast? A lot of what? There you go, a lot of force. That's why you have to study what? Acceleration before you study what? Newton's laws of force and motion. That's why. It's all an acceleration game. All right, so if a pilot accelerates, which, okay, everyone, imagine I'm the pilot. What's my speed right now? 0. In 1 second, that pilot is going to be traveling at a speed of about 40 meters per second. Go ahead, multiply 40 by 3.6. Let 39.2. Let's say 40. Okay, multiply it by 3.6. Let's give it a kilometer per hour sense. Go ahead. What's 4? Sorry, what's 40 times 3.6? What? So everyone, I want you just to imagine this. What's my speed now? Imagine if after 1 second I went from 0 to what? 144 kilometers per hour. That definitely took a lot of what? A lot of force on my back to what? To speed me up that much. Okay? All right. So uh, he begins to gray out. Okay? So graying out is basically kind of like what? Basically like fainting a little bit. Okay? But doesn't completely what? Lose consciousness. Okay? Because of the circulation in their head. Assuming constant acceleration. So assuming the 4G was applied the whole time as a constant rate of acceleration. What is the shortest time that a jet pilot, starting from what? From rest, obviously the plane is still like stationary. From rest can take to reach, can someone read that word? Mach 4. How many people remember the Mach from grade 11? What does Mach 4 mean? Or Mach 7? Or Mach 1? Say again? So if something travels at Mach 1, that means it's traveling exactly at the speed of what? Around it. How about Mach 2? Twice the speed. 3. And so on. So that means what? The question is, how much time at an acceleration of 4 Gs would it take to go from 0 speed to 4 times the speed of sound, which is Mach 4? Okay? Well, first of all, we need the speed of sound of Mach 1. How much is it? By the way, is this number very close to the one we dealt with in grade 11? Yeah, slightly. Yeah, depending on the book you read or the measurement produced or made, usually the number is 331, 332. The number we took in grade 11 was 331.4. More or less, it's the same. Okay, so do you think we need the diagram for this? Or is it more or less the same diagram for the baseball? What was the initial speed of the baseball? 0, just like the pilot. What was the final speed of the baseball? 45. What's the final speed of the pilot? Mach 4, which means we can multiply this number by 4. Okay. So how many numbers do we know so far? 2 numbers. The 0, the Mach 4, but we also know the what? The rate of acceleration or just the acceleration. Perfect. And G is what? G is 9.8. Okay. By the way, our book uses 9.8. Sometimes, depending on the formula sheet in university, they give you 9.8, they give you 9.81. It depends. Okay. So no need for a diagram. Let's actually start with the what? With the numbers. So VI, sorry, VI equals rest, which means 0. Acceleration equals 4 times 9.8. And Ammar said 39.2 meters per second squared. No need for the unit. Everything is standard so far. Speed. Is it VF or VI now? VF. Okay. We need to multiply 4 times 331. Well, 4 times 300 is 1200. And so 1200 and 120 is 1324, is it? In meters per second. And what's A asking for? A asking for what is the shortest what? Time. So we need delta t. Okay, what's missing from this equation? Sorry, what's missing from this list? The distance. Which equation has no distance? Which equation has no delta d in it? By the way, don't memorize. Always look at the table. The very first one, the defining equation for acceleration. All right, all we have to do is plug in and see if we need, sorry, I mean write it and see if we need just to plug in or do some quick algebra. So A equals VF minus VI over delta t. All right. What's my A? Well, 39.2. Should I put it above 1? Yeah, eventually we know cross multiplication is going to have to happen. So over 1 equals, okay, let me just move these. Go ahead, you can keep going. Move this up. There we go. What's the final velocity or speed? Speed, no velocity. 1 through T4, 1324. What's the initial? 0. Perfect. So really just 1 through 1324 over delta t. Great. Rest, cross. So that means 39.2 delta t's equaling 13324. Done. We can just what do you call it? Divide. So delta t equals that big number over 39.2. Okay. How much would that be? 1324 dividing 39. What's the specific situation in this? What did they give us this sound speed? The speed of sound as how many sig figs? 3. What about the 4G? Do you think this 4 is measured or counted? Yeah, the way they say it, it's usually what? Counted. So by the way, again, if I give you a question like that, I might actually say 4.5G or something, and then it becomes a sig fig. So just 3 sig figs. What would that be to 3 sig figs? Cut it at 3. Yep, 33.77. This 7 is going to bump the first 7 to an 8. So 33.8 in what unit? It's a time, so it's seconds. So to accelerate that person, that pilot, from 0 to 4 times the speed of sound using an acceleration rate of 4 times gravity, it will take slightly what? Slightly over half a minute, slightly over half a minute. Okay, 33 point, about 34 seconds. 34 seconds of enduring that. Hey, better than a shorter time because that will mean even more force. Okay, Josh, what's part B? Part A was time. Part B. So during that speeding up phase, how much distance in space would the would the plane have gone through? Obviously, this is an approximate, so we should not use it. So again, we should go back to the original list. Oh, by the way, this is part A. So part B, same list, but now we want delta D. So which equation are we going to use now? We don't need time, or we don't care for it, so it is the last one. Okay. By the way, everyone, are you now seeing which ones get used more? Number 5 is very common. Number 5 is very common. Usually, number 3, the one with the VI, is very common, and the first one, acceleration, is as well. Okay, so let's use the. Sorry, which one did you say? Number 5. So V squared F equals V squared I plus 2A delta D. All right. Final speed is 1324 squared. Good news about VI, it's zeroed out. I don't like to say canceled. It's not canceled. It is 0. And then equals 239.2 delta D. Delta D. Yeah. There we go. Okay. So delta D would be what? That huge square divided by double 39.2. So delta D equals 1324 squared all over 39.2, 78.4. Okay. All right. Let's see what this is. 1324 squared. That's over a million divided by 78.4. Okay, let's see how much the plane traveled just while accelerating to that speed for Mach 4. Whoa. So 22,359. We're still looking for 3 sig figs. So we should cut it at the 3. What should be? Obviously, you can just cut it at the 3 and make it 4 and just write 22400, or do it in scientific notation and then play with the sig fig. Either way, you'll get the same answer. So it is 22400 meters. If you leave it like that in a university course, you're gonna lose marks. Can you guess why? It's a correct answer. But what's not so good about this? It's a big number in what unit? In meters. What's a more friendly one with such a magnitude of a number? What has this is already in the thousands, so it should be what? It should always try to what? Kilometers or miles, but obviously it's easier to do kilometers now. So you divide this by 1,000, or you move an invisible decimal point here, 3 hops back, so 22.4 kilometers. Wow! In slightly over half a minute, that plane traveled 22.4 kilometers, roughly the distance from Westminster to my house back and forth, in only 33 seconds or 34 seconds. Yep, that's 4G. Okay, so I'm hoping that the idea of doing the kinematic equations now is sinking even more and more. Just keep imagining the situation in your head. Thought experiment. Okay, I'll give you a minute to read the next one. So go ahead, flip the page. Just give it a read. Remember, every physics problem is its own trick. It's its own story. So the more you read, the better you become. Yes, sure. Anyone still copying? Okay, another biology application. Airbag injuries. So during an auto accident, okay, are we talking about acceleration or deceleration? We should be talking about deceleration. Okay. By the way, either the deceleration of the person or the acceleration of the what? Of the bag. So it depends. The vehicle's airbag deploy and slow down the passenger more gently than if they had the windshield or steering wheel. According to safety standards, the bags produce a maximum acceleration of 60 G that lasts for only 36 milliseconds or less. Wow. So that means what? The how far meters does a person travel in coming to a complete stop in 36 milliseconds at a constant acceleration of 60 Gs? So to a complete stop, what does that mean? Zero speed initially or finally? Finally. Okay. So the question is saying you've got VF 0, you've got final velocity of 0, you've got how much time to stop? Only. Now, what's a small m? Do you remember from the I should actually print it and give it to you. Maybe, yeah, before we. What's a small m? Millimeters, right? Millimeters, milliseconds, milligrams, and so on. Okay, so you only have 30 seconds, sorry, 36 parts of 1,000 seconds to stop at a constant deceleration, really, of how much? How much? 60 Gs. The force acting back on you is 60 Gs, but it's only applied for how much time? 36 milliseconds. Okay, obviously, if it's applied for longer, that's a bone shattering force. So it's only 36 milliseconds. Okay, so let's put the numbers or the values. Okay, so VF is how much? 0 meters per second. Acceleration. Should we put it as 60 G or negative 60 G? Everyone, remember, you are not speeding up, you are slowing down. So are you gaining speed or losing speed? When you lose speed, are you really accelerating or decelerating? So are you positively accelerating or negatively accelerating? That's why your A has to be what? Negative 60 G. Okay? So negative 60 times what? 9.8. Okay, that's a huge number. Oh, but you know why? Because it's 6 times 10 times 9.8. So the 10 will take care of what? Moving the, what do you call it, the decimal point, and the 6 will just magnify number. You're right. So 60 times 9.8. Yep, negative 588 meters per second squared. And what else do we know? Delta T. Does anyone remember the power of 10 for the milli? No, the power of 10. Let's write it as a power of 10. And by the way, milli are what? Positive powers or negative powers? They have to be small, so they have to be negative powers. But what negative is it? And by the way, it has to be a negative multiple of 3. It's negative what? It's negative 3. Because negative 6 is what? Does anyone know the name for anything with times 10 to the negative 6? Okay. Micro. Does anyone remember negative 9? Something technology, nanotechnology. Okay, so negative 3 is really the biggest scale, which is the only one, by the way, that you can see with the naked eye. Can you see Can you see the millis on the ruler? Yeah, you can. That's the smallest you can see. So times, as many of you said, times 10 to the negative 3 seconds. And VF, A delta T, is the question asking for the initial speed or for the distance it took to stop? Yes. How far? In meters. That's fine. So that means what? We need delta D equal question mark. Okay. What is missing from this list? VI. Which equation is missing VI? Wow. First time to use that. Number 4. Because number 4 is the only one concerned with purely VF, not the VI. Okay. So we write the equation. Delta D equals. Now what's the equation? VF delta T. And is it the minus or the plus case? It's the minus case, and you got the half, you got the A, you've got the delta T, but the delta T has to be what? squared. It's quadratic in time. Yes. Okay, what's the good news about VF? 0, which means whatever it multiplies, it also zeroes it out. So the whole first term here, this entire thing, is killed off because of the what? Because of the VF. Good. So that means this equation reduces to what? Delta D, which is, oh, good news. It's delta D equals, which means really we have what? We have just 0 minus, or just negative 1/2 A delta T squared. Okay, let's keep going. Equals negative 1/2. What's the value for A? Exactly. Everyone, look. What do you get when you multiply negative by a negative? Does it make sense to have a distance positive? You see, if you forgot to make it negative, then you would get what kind of a distance? Which means what? It does, first of all, distance cannot be negative. It has to be positive. Also, even if you interpret it as a displacement, what does negative displacement mean? Are you going forward or backward? But when you stop, you're still technically moving what? You're just losing speed. So it's important to understand that. Good. So negative 588. And the time squared is 6 times 10 to the negative 3, but to a power of 2. Okay? Um, if I would do that in one shot in a single display calculator, do you think I would start from the negative, sorry, from this side, or from this side of the calculation? Yes, I will start from the more complicated side, which seems to be the what? The power of 10 and then square. So I'm going to start from here and make my way back to the left. So look, everyone, just focus on how I'm going to do it just once. So 36. They want to remember how we put times 10 to a power? What button do we use? You can use the times 10, but that's just so elaborate. Or you can just use what? You might have EXP in capital or small or EE or E. All of them do the same job. So I'm just going to write 36. Look, everyone, 36 E, and it's just waiting. What's your power? My power is what? 3 negative. I have to put 3 negative. No need for brackets anymore. It understands now this thing is one single block, one single unit. What am I going to do with it first? Yeah, I don't even need to put it in brackets. If I did the multiplication, I would have had done brackets because it doesn't understand the X notation. So square it. Where is it? Square it. Times what? Now, do I really need to put the negative? We already worked it in our head that negative is a what? Positive. So everyone, whenever you plug in, always minimize how many times you punch in. Do stuff in your head and then just make it easy. So just times 588 times what? Times half, or divide by 2. Okay, so times a half. There we go. Does that make sense? Yeah, it does. This number is very small. If you square it, it even gets smaller. So even with this big number, it's still kept small. What's the specific situation in this problem? Let's look. Sorry. 2. Do we only have one? Oh, again, 60G is counted, so 2. All right. So what would this be to 2 sig fig? 2 sig fig. 2 non-zero decimals. 0.3. So that means, sorry, 0.38 what? Again, it's a distance, and so far everything has been standardized in units. By the way, just so you know, everyone, this doesn't always happen to be the case in first year physics. It's not always going to be given to you in nice, clean meters per second. Oftentimes, they will use miles and kilometers and feet. It just happens that the problems I chose minimize that effect. Meters. What would that be to a better unit? It's a small amount in meters. What would it be good in? Yeah, I mean, if you have meters, the easiest one to convert to is centimeters. So you multiply this by 100, 38 centimeters. How long is 38 centimeters? 38 centimeters is this. So if you're here, how far are you going to go? Here and a little bit what? More. So from here to here. That's how much you're gonna move. So if I come here, I'm gonna move up. Make sense? That's really kind of what happens with what with airbag. Okay. By the time you come to a stop, you moved about 38 centimeters. Nice. Okay. Last problem, number 4 for today. Okay. This is an elaborate problem. Why? It's multiple stages. It's multiple stages. So, Mars landing. In January 2004, NASA landed exploration vehicle on Mars, part of the descent. What does descent mean? When something descends, what does that mean physically? It's going what? It's going down. What's the opposite of descent? Ascent. Ascent, descent. So part of the descent consisted of the following stages. Stage A, friction with the atmosphere, because you're in vacuum first, and then you start getting into what? Into the atmosphere of Mars. Reduce the speed from what? From what? 19,300 kilometers per hour to what? To 1,600 kilometers per hour in how much time? Great. So apparently, for stage 1, what is the 19,300? Initial what? Go ahead, everyone. So write VI here. For this stage, we're going to do the symbols per stage. So for this stage, VI is this guy, which means this is what? VF, great. And this would be what? Delta time. Yeah, sorry, delta T, time. Perfect. Stage 2. A parachute then opened to slow it down to 2. So what's that after 2? Again? I didn't hear it. Sorry. Come on. Safe zone. Come on. Final speed. But so what was the initial one? The final from the previous stage, right? Remember, every stage picks up immediately after the stage before it. So that means for this stage, this 321 is not the initial speed. It's the what? It's the final speed. What's the initial speed for this stage? The final speed of the initial stage. Remember, it's a string that you connect end to end or end to beginning. So that's VF. Sorry, that's yeah, that's VF. That's VF for this stage. Again, another delta time. Okay, stage C. Does anyone know what's retro rockets? Does anyone? I know if you watch like space movies or The Martian and so on. What's the retro? Yeah, exactly. So they are rockets, but instead of propelling you forward, they push you what? Retro means back. Okay. Then fire to reduce the speed to what? What is this zero again? It's what? It's VF for the final stage. Yes. Over a distance now, not time, distance. Okay. Assume that, as I said to Jinan, each stage followed with no delay immediately from the stage before it, and that the acceleration during each stage was constant. It wasn't the same each time, but during each stage, it was a constant deceleration, really, not acceleration. But remember, what did I tell you? The only word we use is usually what? But we mean it's negative now. Okay. Find the rocket's acceleration during each stage. Okay. Let's look at the. Okay, so part A is going to consist of. How should we do this? Okay. So we have 3 stages. They want the acceleration in each one. Also, they want the distance in each one. Which stage do we only know the distance of? C. For part A and B, we do need it. So everyone, I think it would be a smart decision, everyone, to divide the slide or whatever to what? 3 parts. So go ahead. One part here, that will be the part for stage A. And one part here for stage. Oh, uh, rulers, anyone? I'm cleaning up the rules, so I'm gonna give you the small ones. Rulers? Good? Okay. All right. What do we know about stage A? What information do I know about stage A? We already labeled them. Hmm. So, sorry, the VI, the VF, the delta T. Okay. The VI, which is how much? Okay, your VI is given in what unit? Come on. But your time is given in what? No, no. For stage A, sorry, for stage A. It's given in minutes. Now, by the way, did they tell you to find they told you to find the acceleration in what? Meters per. So you need to convert all the distances from kilometers to meters and all the times from anything to what? To seconds. Okay. Um, okay, that's good news. Can we use the trick of converting now between kilometers per hour and meters per second? Yes, we can. What's the magic number? What's the magic number from kilometers per hour to meters per second? 3.6. But my question now is, am I going to divide this by 3.6 or multiply it? And you have to tell me why you choose one of the ends. Ammar, say again? Why? Exactly. Well, okay. Exactly. We want a smaller scale, right? I want to go from hours to what? For seconds. So I definitely need to scale it down. 3.6 division scales it down. Okay. So everyone, let's divide right now. Okay. I'm gonna do the divisions and write the answers right here. All right. Um, 19 is 19 what? Like what's the speed? 19. 300 divided by 3.6. Okay. Um, so that could be, we can just use it at 5361. All right, everyone. 55361. Final speed. What was the final speed in kilometers per hour? So 1600 divided by the magic number 3.6. Okay, how about 444.4? By the way, I'm just keeping one extra sig fig in the intermediate step. 4444. And my time, obviously, it has to be in seconds. How many seconds is 4 minutes? 4 minutes. What do you do? 4 minutes. 240. You multiply by 60. Okay. We are looking for, do they want acceleration in part A or what? What do they want acceleration? Okay, so I want a question mark. What's missing from here? What's missing from here? Distance. What equation does not have distance? Which one? First one, which is actually good for me because A on the left side is equal to all of these combined on the right side. So pure plugging in. Nice. So everyone, let's do it in one shot. A equals 444.4 subtract 5361 all divided by 240 seconds. All right, I'll do it. 444.4 subtract 5361 divided by 240. Yep, negative as expected. The module, the landing vehicle, was losing 20.5 meters per second every single second during stage A only. So negative 20.5. And because this is the final answer, I'm going to put a unit. Meters per second squared. Nice. Okay, stage 2. What's the initial speed of stage 2? What's the initial speed of stage 2? Exactly, the final speed of stage 1. So VI for stage 2 is the 444.4. Okay, what's the final speed of it? How many? Just the final speed of stage 2. 321. All right, let's divide that by 3.6. 321 divided by 3.6. I'll go with 89.17. 89.17. Okay, am I given time or distance for that stage? Time. Okay, and what is it? 94 seconds. 94 seconds. Okay, and I still want acceleration. Okay, what's missing here? Same thing. What's missing is distance. So A again is, what is it? 89, 17, subtract 444.4, all dividing, what? 94. I'm going to squeeze this a bit. You can keep going. Just cleaning up. There we go. What is that? Negative something. 89.17 minus 444 divided by 94. How much? Now, what's the sig fig situation here? 94 has how many? Has 2. So we have to keep it to 2. What would this be in 2? Negative 3.77 becomes negative 3.8 meters per second squared. And for the last stage, my VI becomes the VF from here. Each one picks up. What's the V final for the last stage? Last stage. 0. It came to a stop. Pure 0. And we're given distance apparently. How much distance they take to stop? 75 meters. Again, 2 sig figs as well. Acceleration. What's missing now from this list? Time. Which equation has no time? Last one, number 5. So VF squared, VI squared plus 2A delta D. Hey everyone, what's the good news about VF in this stage? 0. So that means the entire left side, this guy, look, this guy is zeroed out. Which means 0 equals VI. Sorry, just give me a second. What's the VI? 8917. Don't forget the square. Plus 2 times 75 is 150. 158. So if you move this guy, look, you're going to have to move this guy here before squaring it or after squaring it. It has to be squared at some point. So you will get this. A equals negative 8917 squared divided by 150. Yes, Josh. Why is it negative? Because this guy is going to have to move here, right? Because I'm trying to solve for this guy, right? Again, by the way, you could have moved this guy here, right? Doesn't matter. At some point, a negative has to be generated, which makes sense physically. Why? Because we're slowing down. So let me just take out the circle. Okay. So what do we get? I don't know. Let's divide. Please. Thank you. Okay. I was waiting for someone to say that. Who? I agree with you, but look at how I wrote it. Not only that, did I put a bracket around the minus? No, you remember what math teachers always tell you? This, look everyone, is this and this the same thing? No, they're not. Which one definitely is positive, the first or the second? Because the minus has been what? Has been squared. How about the second one? Technically, the square is only applying to what? To the 4 only, and the minus just goes along for the right. Is it making sense now? The way I wrote it is exactly the way you're supposed to mathematically say it. Okay? But you're absolutely right. I need to be careful. I should square first and then what? Negate. Unless I write it this way, I know exactly what to do. Perfect. Yes, you are absolutely right. Otherwise, you're going to get a positive acceleration, which makes no sense. So that means, everyone, look, to Ammar's point, I'm not going to do this. I'm not going to do 8917. Sorry, 17. Negative, and then what? Because then I'm going to generate what number? I don't want that. I want to be what? So I'm going to square first, 89 point. Or I could do this. Bracket, 8917. Close the bracket, square it, and then negate it. Who cares? Just do something. Okay, but you're absolutely right. Good observation. Divided by 150. Uh, that's the thing. I do so much in my head already. I just keep the calculator to what to the number calculation. But I know physically and mathematically my answer should be what? Negative at the end. You're right. So the sig fig situations here are 2, because this 75 was 2. So what would this be to 2 sig figs? Just 2. Negative 53 zeros don't count. So negative 53 meters per second square. I will leave part B to you. Part B is calculating the what? The full distance of descent. We already have one of them, stage 3. You just have to calculate the distance for part A, sorry, from stage 1 and stage 2.